All right, today we're going to learn about how to solve equations with variables on both sides. So we're going to start off with something called the vertical line method. And what you're going to do is you're going to find your equal sign and you're just going to draw a vertical line like so where you see the equal sign. Our goal with the vertical line method is to get all the variables over here on this side and all the constants over here on this side. Okay, so we're going to start over here at the beginning. First we see a 2x. The 2x is on the correct side, so we're going to bring it straight down. The next thing that we see is a positive 1. The positive 1 needs to be moved to the right side. Now, when you cross this vertical line right here, then your sign is going to change. So instead of being a plus 1, it's going to become a minus 1 because it changed sides. Next, we have this x. He's also on the wrong side, so I'm going to move him over here, and his sign is going to change since we crossed the vertical line. So instead of being positive x, it becomes negative x or minus x. The plus 11 is on the correct side, so he's going to just stay exactly like he is, bring him straight down, and he stays plus 11. Now you have all of the variables over here on the left. You have all of the constants over here on the right. So we just combine our like terms. 2x minus x is x. We'll go ahead and bring down our equal sign. On the right side, we have negative 1 plus 11. Negative 1 plus 11 is 10. So our answer is going to be x equals 10. That's it. Let's try that again. Let's slide over here to problem number 2. So for problem number 2, like I said, you're going to start off with a vertical line where your equal sign is. All right, and then start at the beginning. Your variable here is an a, and that is on the correct side, so that a comes straight down. Next, we have a positive 2. That needs to be moved over here to the right side, so its sign changes. So instead of positive 2, it becomes negative 2. We have a positive 5 is next. That is on the correct side, the side that it should be on. So it's going to stay positive 5, and I'm going to put plus 5 right there. And then we have a plus or a positive 4a. That is not on the correct side. So it's going to move over here. Since it crossed the vertical line, it becomes a minus 4a. Now we're going to combine our like terms on each side. So again, over here we have a minus 4a. Remember, that's the same as 1a, if you want to think of it that way, minus 4a. So that becomes negative 3a. We'll bring down our equal sign. And then here we have negative 2 plus 5. Negative 2 plus 5 is going to be positive 3. A is still not alone. Remember that negative 3a means negative 3. It means this, negative 3 times a. So we're going to do the opposite of multiplication, which is division. So I'm going to divide both sides by negative 3. That leaves me with a equals, and then 3 divided by negative 3 is going to give me negative 1. So my answer is going to be a equals negative 1. All right, moving on to problem 3. You're going to start off by making your vertical line. The 4 is on the wrong side. We're going to slide it over here, which means instead of a positive 4, it becomes a negative 4. This minus 3b is on the correct side. I'm going to just slide it over here. So it stays minus 3b or negative 3b. Next up is 6b. That 6b needs to come all the way over here. And instead of being positive 6b, it becomes negative 6b. Then the minus 5 is on the correct side, so we're going to bring it straight down. We're going to combine our like terms now on each side. So that says negative 3b minus 6b. So that's going to give me negative 9b. Bring down your equal sign. Again, over here that says negative 4 minus 5. And that's going to give me negative 9. Now you still don't have b alone. Negative 9b, remember, is the same as negative 9 times b. So we're going to use division. So we're going to divide both sides by negative 9. That leaves me with b equals 1. And then we're going to just highlight that final answer. So my final answer here is that b is equal to 1. All right, let's go to problem 4. So looking at number 4, again, we're going to start off by drawing a vertical line. We want all the y's over here on the left. 7y is already on the left, so he's coming straight down. That plus 25 is not on the side I want it to be on, so it's going to come over here. Since it's crossing, since it crossed the vertical line, instead of positive 25, becomes negative 25. Then the 2y is not on the side I want it to be on. So it's going to come over here on this side. Again, since we're crossing the vertical line, its sign changes, so it becomes negative 2y. So that leaves me, I'm going to combine my like terms. 7y minus 2y is 5y. Bring down your equals. And on the right side, all you have now is negative 25. Again, 5y means 5 times y. So we're going to divide, and we're dividing both sides by positive 5. So that leaves me with y equals, and that negative 25 divided by 5 is negative 5. All right, let's do another one. Okay, again, and we're doing the vertical line method when we have variables on both sides to make it easier. So we start at the beginning just like you're reading a book. First thing we see is a 7. That is a constant. It needs to slide over here to the right. And its sign has to change because it crossed the vertical line. This minus 4c is on the correct side, so I'm going to bring it straight down, and it stays negative 4c. On the right over here, I have a 3c. He needs to come over here. His sign changes. Instead of positive 3c, it becomes negative 3c since we crossed that vertical line. And then that minus 7... Oops, sorry about that. That minus 7 is on the correct side, so its sign stays the same. It comes straight down. Now we just combine our like terms. So I have negative 4c minus 3c. So that's going to give me negative 7c. We'll bring down the equals. We don't need the vertical line anymore. On the right side, that says negative 7 minus 7. That's not 0. That's going to give me negative 14. So now I've got negative 7c is equal to negative 14. So we finish off by dividing both sides by negative 7. That says negative 14 divided by negative 7, which is positive 2. So my solution is that c is equal to 2. All right, look at problem 6. I see I have variables on both sides again. So vertical line. Start at the beginning. 12c is on the side he needs to be on, so he stays. Plus 18, cross that vertical line, becomes negative 18. 4 is on the correct side, so it stays positive 4. So I'm going to just write a plus in front of it this time. And then that plus 5c is on the correct side. Is on the incorrect side. So it's going to come over here. It's going to change signs and become a negative 5c. We're going to combine our like terms. So I see 12c minus 5c. That gives me 7c. Bring down the equals. On the right-hand side, negative 18 plus 4 is negative 14. Finish it up. You're going to divide both sides by 7. So c is equal to negative 2. All right, I want you to just pause the video for a second and try problems 7, 8, and 9 on your own, and then you can come back and see. All right, so here are the answers for problems 7, 8, and 9. go ahead and pause the video so that you can check and see if you got them right. Okay, now that you're back, let's go ahead and look at problem 10. Now this time we have parentheses, and we are still going to use our vertical line method. But before you use your vertical line method, you want to get rid of your parentheses first. So in this problem that says 4 times, and this would be read as the difference between J and 7, that's one way to say it, is equal to 12. So we're going to start off by distributing that 4. Notice I've drawn these arrows here. And so we do that with multiplication. So I'm doing 4 times J, which is 4J. And then I'm doing 4 times negative 7. So that'd be negative 28 or minus 28. Then you're going to bring down the right sides. You're bringing down the equals and the 12. Now that your parentheses are gone, now let's use that vertical line method for this one. So the 4J is on the correct side. So it came straight down. The minus 28 comes over here, becomes a positive 28. The 12 is on the correct side, it stays there. All right, so that combine your like terms. So 4J equals, and then on the right side, I'm doing 28 plus 12, so that's 40. Then finish it up. In this problem, we divide both sides by 4, so we get that J is equal to 10. Now, you may be thinking, well, wait a minute, I didn't need to do this vertical line method once I got here. I just knew add 28 on both sides. And that's correct. Essentially, that is what you're doing. You did add the 28 over here. So the vertical line method, maybe you didn't need to use it for this particular problem once you got here. And that's okay. There's more than one way to solve an equation. I'm just showing you this vertical line method because it's been very helpful for a lot of students, especially when we have variables on both sides. All right, let's go to problem 11. Again, first thing we're going to do is to get rid of our parentheses. So you always want to do that first if that's what you've got. So I'm going to distribute the 5. I'm doing 5 times 2k. So that would be 10k. Then 5 times positive 10 is positive 50 or plus 50. Bring down the equals, bring down the 40. Now you can, if you know how to solve it from here, then by all means. Or if you're unsure, remember we can use that vertical line method. So the 10k is on the correct side, so I bring it down. The positive 50 needs to switch sides, and since it's switching sides, it becomes minus 50 or negative 50. And the 40 is on the correct side, so it stays positive 40. So you're left with 10k over on the left. On the right, that says negative 50 plus 40, so that's negative 10. So now we'll finish it off by dividing both sides by 10 because that was the coefficient of k. Negative 10 divided by positive 10 is negative 1. So we end up, oops, sorry about that, with k equals negative 1. All right, number 12. Now this one's a little bit more complicated, but there are parentheses here. So those are going to be eliminated first. We're distributing a 7. So I'm doing 7 times 2p, so that'd be 14p. Now 7 times positive 3 is positive, so I'm writing a plus, 21. That minus 8 comes straight down along with the equal 6p and then the plus 29. So the rest of it came straight down. Now I can use my vertical line method to help me get everything solved. Start at the beginning. 14p, that's a variable, and it's on the correct side, so it came straight down. The positive 21 is on the wrong side, so it needs to come over here and change signs, becomes a negative 21. The negative 8 needs to come over here. It's on the wrong side, becomes a plus 8. Remember, if you cross the vertical line, your sign changes. 6p has to come over here on this side, and instead of positive 6p, it becomes minus or negative 6p. And then the positive 29 is on the side it should be on, so it comes straight down. Now we can combine our like terms. So I've got 14p minus 6p is 8p. I'm going to bring down my equal sign. And then I'm going to combine this. So I'm going to start off negative 21 plus 8. Oops, sorry about that. So negative 21 plus 8 is going to be negative 13. And then you got to do plus 29. Negative 13 plus 29 is going to give me positive 16. So we're left with 8p equals 16. Divide both sides by 8. 16 divided by 8 is 2. So I'm left with p equals 2. Let's do another example. Let's go to number 13. Again, parentheses. So we're going to get rid of that first. 7 times g is just 7g. 7 times negative 4 is negative 28, so minus 28. Then I bring everything else down, in this case the equals and the 3. I'm going to use my vertical line method here. So I'm going to start off, the 7g comes straight down. The minus 28 comes over here, becomes a positive 28. And then the 3 is on the correct side, so it stays, and it becomes a plus 3. We combine all of our like terms. So I bring down the 7g, bring down the equals, and then 28 plus 3 is going to be 31. So I know this one looks a little bit tricky. That's okay. We're going to divide both sides. The next step is still to divide both sides by 7. Bring down your g and your equals. And so I'm left with 31 divided by 7. 31 is not evenly divisible by 7. So we could either try and change it to a decimal, or we can just leave it as an improper fraction. And a lot of times in math, that's what we do. So our answer here is going to be 31/7. And that's okay. Not when you solve an equation, not every answer is going to be a perfect answer. It's not always going to be an integer. Okay? So 31/7 is perfectly acceptable. All right, let's go to 14. This time you have 2 sets of parentheses, one on each side. So again, you're going to have to get rid of them. We're going to start off by distributing to get rid of them. I'm going to do 2 times a, that's 2a. Then 2 times negative 1, which is negative 2 or minus 2. I'm going to bring down the equals. Over here on the right, I got a negative 3 times a. I'm sorry, positive 3 times a, which is 3a. And then positive 3 times positive 1 is positive 3 or plus 3. Now I can use my vertical line method. So I'm going to draw in that vertical line. Start over here with the 2a. It's on the correct side, so it comes straight down. Then that minus 2 needs to switch sides. So instead of being a minus 2, it's a positive 2. 3a needs to come over here. Since it's switching sides, it becomes a minus 3a. And then the plus 3 is on the correct side, so you come straight down and just stays plus 3. We can combine our like terms now. 2a minus 3a is negative 1a, or you might just say negative a. And then on the right, that says 2 plus 3, which is 5. Finish it off. You can divide both sides by negative 1. So a equals negative 5. All right, go to problem 15. Again, we have parentheses on both sides. So we're going to distribute. So we start off with doing 3 times x, which is 3x. 3 times negative 3 would be negative, so minus 9. Bring down the equals. Over here on the right, we're distributing a 5, and I've got to do 5 times 1.5. So 5 times 1.5 is going to be 7.5. And then I'm going to do 5 times positive x, so that'd be plus 5x. All right, we're going to apply our vertical line method here. So the 3x can come straight down. That minus 9 is going to come over here to the right and become a positive 9. The 7.5 can come straight down. It's on the correct side. And then the plus 5x switches sides and becomes a minus 5x. All right, so we've got 3x minus 5x. We know that that is negative 2x. And now we have 9 plus 7.5. So 9 plus 7.5 would be 16.5. We're going to now divide both sides by negative 2. And that's going to give me negative 8.25. This time I left the answer as a decimal. And the reason I decided to leave this one as a decimal is because we were dealing with decimals within the problem, okay, instead of an improper fraction. All right. Now, let's see what you can do on your own. So, take a minute, and I want you to pause the video and then do problems 16, 17, and 18. All right, so here are the answers for 16, 17, and 18. Go ahead and pause the video so that you can check over your answers. Okay, so these were all a little tricky. Notice that none of them came out as perfect integers, and again, that's okay. We want to make sure that you understand the steps. I do want to just point out on problem 18, notice that right here is where a lot of people make a mistake. So that 1 comes straight down. When you distribute here, you're distributing a negative 2. So negative 2 times b is negative 2b. And then you're doing negative 2 times positive 6. So you should have had a negative 12 here, not a positive 12. If you have positive 12 here, then that would have messed everything up in solving the equation. Okay, so again, I hope that you enjoyed this video, and good luck.